హలో ఆల్ వెల్కమ్ బ్యాక్ టు అవర్ ఛానల్ చమకు స్పార్క్స్. సో ఇవాళ మనము ఇంటర్మీడియట్ ఫస్ట్ ఇయర్ కెమిస్ట్రీ సిలబస్లో చాప్టర్ 2 క్లాసిఫికేషన్ ఆఫ్ ఎలిమెంట్స్ అండ్ పీరియాడిసిటీ ఇన్ ప్రాపర్టీస్. సో మనము ఈ చాప్టర్ నుంచి అకార్డింగ్ టు బ్లూ ప్రింట్ మనకు ఒక ఎస్ఏ క్వశ్చన్ వస్తుంది. సో ఇందులో మనకు అకార్డింగ్ టు ప్రీవియస్ పేపర్స్ రిపీటెడ్ క్వశ్చన్స్ అండ్ ఆల్సో ఇంపార్టెంట్ క్వశ్చన్స్ కంప్లీట్ చేసుకుందాం. సో మనకి ఇక్కడ ఫస్ట్ క్వశ్చన్ చూడండి. What is periodic property? How are the following properties vary in a group and in a period? Explain. మనకి ఇక్కడ మనకు 5 ప్రాపర్టీస్ ఇచ్చారు. మనకు ఈ 5 ప్రాపర్టీస్లో మనకు గ్రూప్లో అండ్ పీరియడ్లో ఎలా వేరీ అవుతుందో మనం ఇక్కడ చెప్పాలన్నమాట. సో వీ హ్యావ్ అయనైజేషన్ ఎంథాల్పీ, ఎలక్ట్రోనెగటివిటీ, అటామిక్ రేడియస్, ఎలక్ట్రాన్ గెయిన్ ఎంథాల్పీ అండ్ నేచర్ ఆఫ్ ఆక్సైడ్స్. So first manaku what is periodicity? The properties of elements repeats itself at regular intervals is known as periodicity or periodic properties. So this is periodicity. So first property manaku enti ionization enthalpy. So what is ionization enthalpy? The amount of energy required to remove an electron from outermost orbit of an isolated neutral gaseous atom is known as ionization enthalpy or ionization potential. So manaku group lo and period lo ela vary avutundi? In a group from top to bottom, atomic size increases, ionization potential value decreases. మనకు పీరియడ్లో ఎలా అవుతుంది? ఇన్ అ పీరియడ్ ఫ్రమ్ లెఫ్ట్ టు రైట్ అటామిక్ సైజ్ డిక్రీజెస్ అండ్ అయనైజేషన్ పొటెన్షియల్ వాల్యూ ఇంక్రీజెస్. సో దిస్ ఈజ్ లైక్ వైస్ వర్సా. ఓకే, సో అయనైజేషన్ పొటెన్షియల్ వాల్యూ ఈజ్ not proportional to 1 by atomic size. Okay, so next one, electronegativity. What is electronegativity? The ability of an atom to attract the bond pair electrons towards itself is known as electronegativity. In electronegativity, the bond pair of electrons, they attract, the atom attracts the bond pair of electrons towards itself. So that is known as electronegativity. Okay, so how does it vary in a group? How does it vary in a group and in a period? Okay, in a group from top to bottom atomic size increases. So this is a small trick to remember. Here in any of the periodic property from top to bottom atomic size always increases, and in the period from left to right atomic size always decreases. It may be any of the periodic property, but atomic size will be increasing from top to bottom, and in the periods from left to right atomic size will be decreasing. So the property which is not directly proportional to the atomic size will be vice versa. Okay, I hope you all understood what I meant. So the next one, atomic size. Atomic size is directly proportional, atomic radius is directly proportional to the atomic size. So this is, what is atomic radius? The distance between the nucleus and outermost electron of an atom is known as atomic radius. So it is directly proportional, so the both will be same. In group from top to bottom atomic radius increases because new shells are added. In period from left to right atomic radius decreases because nuclear attraction increases on the outermost shell. Okay, coming to the fourth property, periodic property, electron gain enthalpy. The amount of energy released when an electron is added to the valency shell of natural neutral gaseous atom is called electron gain enthalpy. Okay, this is electron gain enthalpy. And in group from top to bottom atomic size increases, so electron gain enthalpy decreases. In period from left to right atomic size decreases, electron gain enthalpy increases. Coming to the last periodic property, nature of oxides. Generally metal oxides have basic nature and non-metal oxides have acidic nature. So in group from top to bottom metallic nature of elements increases, so basic character of oxides also increases. In a period from left to right non-metallic nature of elements increases, so acidic nature of oxides also increases. This is the metallic nature, another property. The tendency of an element to lose electrons is called metallic nature. So atomic radius and metallic nature are both directly proportional. So let's see the variation in a group. In a group from top to bottom, metallic nature gradually increases due to increase in atomic radius. Okay. Let's see the variation in a period. In a period from left to right, metallic nature gradually decreases due to decrease in atomic radius. So let's move on to the next question. Define IE1 and IE2. Why is IE2 greater than IE1 for a given atom? Discuss the factors that affect ionization enthalpy of an element. So what is ionization enthalpy 1? The amount of energy required to remove an electron from outermost orbital of isolated neutral gaseous atom is called IE1. This is the formula. And what is IE2? The amount of energy required to remove an electron from unipositive gaseous ion is called IE2. This is a formula. So why is IE2 greater than IE1? Because in unipositive ion, number of protons are more than number of electrons. So the nuclear attraction increases on electrons. So that's why IE2 is greater than IE1. So let's see the factors affecting on ionization enthalpy. First one, atomic size. As atomic size increases, ionization enthalpy value decreases. As atomic size decreases, ionization enthalpy value increases. So ionization enthalpy value is not directly proportional to 1 by atomic size. Let's see the next factor, nuclear charge. As nuclear charge increases, ionization values also increases. If nuclear charge value decreases, ionization enthalpy value also decreases. So this is a formula. It is directly proportional. Ionization enthalpy value is directly proportional to nuclear charge. Let's see the next factor, screening effect. If screening effect increases, ionization enthalpy value decreases. If screening effect increases, ionization enthalpy value increases. So ionization enthalpy value is not directly proportional to 1 by screening effect. The last one, electronic configuration. Half-filled or full-filled orbitals of an atom are more stable. So they have more ionization enthalpy value. So this is another important question. Write an essay on S, P, D and F block elements. Depending upon the entering of differentiating electron into the atomic orbitals, the elements of long form of periodic table are divided into 4 blocks. They are S, P, D and F blocks. So first, S block. The elements in which the differentiating electron enters the S sublevel are called S block elements. In this block, there are 2 groups. They are 1A and 2A. The valence electron configuration of elements of 1A group is NS1 and that of 2A is NS2. So 1A group is NS1 and 2A is represented by NS2. The elements of 1A are alkali metals and 2A are alkaline earth metals. Okay, these are metals and highly reactive. Okay. Coming to the P block, the elements in which the differentiating electron enters the P sublevel are called P block elements. In this block, there are 6 groups. They are 3A, 4A, 5A, 6A, 7A and 0. The valence electron configuration of the elements of these groups varies from NS2, NP1 to NS2 to NP6. Okay. It includes metals, non-metals, metalloids and noble gases. Coming to the D block, the elements in which the differentiating electron enters into D sublevel are called D block elements. In this block, there are 10 groups. They are 3B, 4B, 5B, 6B, 7B, 8B, 1B and 2B. The general outer configuration of D block elements is N1, n minus 1 to d, 1 minus 10 to ns, 1 to 2. Okay, d 1 to 10. Okay, these elements are also known as transition elements. These are all metals having high Hp and Bp. Coming to the last block, F block, the elements in which the differentiating electron enters into f orbital are called f block elements. In this block there are 14 groups. They have no designation. Their general outer configuration is N2 F1 to 14, N1 D0 to 1, and S2. The F block elements are arranged separately at the bottom in two rows. The elements of first row are called lanthanides, and in these elements the valence electron enters into 4f orbital. The elements of second row are called actinides, and in these elements the valence electron enters into 5f orbital. All the f block elements are also known as inner transition elements. They are all metals.